Imagine you're riding a bullet train at 250 kilometers per hour, 78 meters beneath the ocean floor. That's as deep as a 25-story building. Overhead, cargo vessels navigate one of the planet's busiest shipping lanes. The water pressure could flatten a car like a soda can, and you're casually scrolling your phone. Totally relaxed. Sounds insane, right? Well, it's happening right now in China. They're constructing an underwater tunnel so extreme that when it launches in 2028, it'll shatter every record for submerged rail projects. The Gintang Undersea Tunnel is over 16 kilometers long, with more than 11 kilometers drilled straight under the seabed. Two enormous tunnel boring machines the size of apartment buildings are meeting deep underground with surgical precision, and they're doing it at speeds that make other nations' underwater tunnels look like practice runs. Today, we're going deep into how China accomplished what engineers thought was nearly impossible: the mind-bending accuracy to link two tunnels beneath the ocean, and why this might be the trial run for something even bigger: a tunnel across the Taiwan Strait. Why construct a tunnel beneath the ocean anyway? Alright, so before we dive into how they're doing this, let's address why. Because building a tunnel under the ocean sounds like the type of pitch someone makes after downing too much caffeine. Here's the deal. Zhoushan is a group of islands off eastern China's coastline. Gorgeous location, fishing communities, and home to one of the nation's largest offshore petrochemical facilities. But here's the catch: no rail service. If you needed to reach it from the mainland, your options were catching a ferry or driving over bridges. And bridges aren't particularly fast when you're transporting millions of passengers and massive freight. China's answer? Build a high-speed railway that runs beneath the ocean. You're probably asking, why not just build another bridge? Bridges come with restrictions. They interfere with maritime traffic, and in certain locations, the water's simply too deep. Tunnels can go practically anywhere. They're not bothered by waves, weather systems, or vessels cruising overhead, and China's been on a crusade to connect every corner. Over the past 10 years, they've constructed 45,000 kilometers of high-speed railway, exceeding the rest of the globe combined. The ocean was the ultimate challenge, so they built the Gintang Undersea Tunnel. This isn't some ordinary tunnel. It's engineered for bullet trains racing at 250 kilometers per hour, 78 meters under sea level, in one of the most geologically challenging regions imaginable. Which leads us to the question, how do you even begin building something like this? Introducing the machines? 4,000-ton monsters that devour rock. Okay, let's discuss the headliners here. The tunnel boring machines. And no, these aren't your typical construction equipment. These beasts are genuine giants. The two machines deployed for the Gintang Tunnel go by Dinghai and Yongjiao. Each one measures roughly 150 meters long, which is half the Eiffel Tower's height laid horizontally. The cutting head by itself spans nearly 15 meters wide. Picture a circular blade the height of a 5-floor building, rotating with sufficient power to carve through solid stone like it's soft cheese. These machines tip the scales at approximately 4,000 tons apiece, equivalent to 8 completely loaded Boeing 747 aircraft. And they don't merely excavate, they're completely automated engineering wonders. While the cutting head grinds ahead, the machine simultaneously clears rubble, positions reinforced concrete segments to brace the tunnel sides, and pumps grout to lock everything down. It's like constructing a skyscraper horizontally underground in real time. But here's where things get insane. These machines must handle mixed geology. Throughout the tunnel path, the ground composition isn't uniform. One moment, you're drilling through hard, granite, solid, and predictable. The following moment, you strike loose clay or sandy soil that can shift and collapse. Across the tunnel's length, the machines face 28 separate geological changes. 28 times they must adjust velocity, pressure, and cutting technique to prevent disaster. To handle this, Chinese engineers implemented custom modifications. They added water injection systems to the cutting head to deal with sticky clay that could jam the blades, reinforced the support structures to withstand crushing water pressure at 78 meters below sea level, and upgraded the drive systems to ensure these machines could run continuously for months without failure. Now, you might be curious, how do they coordinate? One machine, Yongjiao, begins excavating from the Ningbo end, the mainland side. It drills almost 5,000 meters. The second machine, Dinghai, launches from the Zhoushan end, the island side. It excavates beyond 6,000 meters, and somewhere in between, deep beneath the ocean, they're meant to connect. But here's the issue, they can't simply wing it. If these two machines fail to meet by even a couple of meters, you don't get a tunnel. You get two independent holes underground leading nowhere. And at that stage, you've just burned billions on the planet's most costly disaster. So how do they ensure these two machines link up with laser precision? That's when things get truly fascinating. The precision challenge, linking two tunnels under the ocean. Alright, so picture you're attempting to thread a needle, except the needle's 15 meters across, it's buried 78 meters beneath the ocean floor, and you're guiding it from over 6 kilometers away. Oh, and if you miss, you've wasted years of work and enough money to fund a developing nation's infrastructure budget. That's essentially what China faced with the Gintang tunnel. The difficulty here is exactness. When you're excavating a tunnel from opposite directions, even the tiniest error in angle or alignment compounds over distance. A deviation of just 1 degree at the starting point could mean you're dozens of meters off target by the time you reach the middle. And underwater, you can't exactly stop and measure things with a tape measure. So how did they crack this? 2 words: Beidou satellites. Beidou represents China's alternative to GPS, a network of navigation satellites providing positioning data with incredible accuracy. But here's the thing. Traditional satellite positioning can be off by a few meters, which is fine if you're driving a car, but completely useless if you're trying to connect 2 tunnel boring machines underground. So, Chinese engineers took it a step further. They deployed 6 Beidou satellites specifically for this project and linked them directly to the auto navigation systems on both tunnel boring machines. These systems constantly track the machine's positions in 3-dimensional space, latitude, longitude, and depth, and make micro adjustments in real time. Think of it like this. Every few meters, the machines send a signal to the satellites. The satellites calculate exactly where they are, compare it to the planned route, and send corrections back. If the machine is drifting even a centimeter off course, the system adjusts the cutter head angle and steering to bring it back in line. It's like having a GPS that's accurate to within 2 centimeters, guiding a 4,000-ton machine through solid rock. And it worked. When Dinghai and Yongjiao finally met deep under the seabed, the alignment error was less than 2 centimeters. 2 centimeters on a tunnel that's over 11 kilometers long. That's the equivalent of threading a needle from across a football field. But now comes the final problem. What do you do with the machines once they meet? Because here's the thing, there's no exit ahead. They can't just keep digging forward, and they're way too big to reverse back through the tunnel they just created. So what happens to these 4,000-ton machines? The VOS final act, when machines become part of the tunnel. Alright, so you've got 2 massive tunnel boring machines that just met up deep under the ocean. They did their job perfectly. High fives all around. But now you've got a problem. These things are stuck. There's no way to drive them out, and there's definitely no way to lift them back to the surface. So what do? You leave them there. Well, kind of. Chinese engineers use a technique called shedding the shell. It's exactly what it sounds like. The machines are carefully dismantled piece by piece from the inside. The drive systems, the cutter heads, the hydraulic components, all the expensive reusable parts are removed and hauled back through the tunnel. It's like gutting a building from the inside until only the skeleton remains. But here's the clever part. The outer steel casing, the massive cylindrical shell that housed all the machinery, stays in place forever. It becomes a permanent part of the tunnel structure, reinforcing the walls and providing extra support. So in a way, these machines don't just build the tunnel, they become the tunnel. It's poetic in a weird engineering kind of way. These colossal machines, designed for one purpose, complete their mission, and then sacrifice themselves to ensure the tunnel lasts for decades. And honestly, it's probably the most practical solution. Trying to extract them would be more expensive and time-consuming than just building new ones for the next project. According to the latest reports, the Gintang tunnel is on track to be fully bored through by the end of 2026. After that, they'll spend another year or so on finishing work, laying tracks, installing electrical systems, safety equipment, ventilation, lighting, all the stuff that turns a hole in the ground into a functioning high-speed rail tunnel. When it opens in 2028, passengers will be able to travel from Ningbo to Zhoushan in just 30 minutes. A trip that used to take over an hour by ferry or car will be reduced to less time than it takes to watch a TV show. And you'll be doing it in air-conditioned comfort at 250 kilometers per hour, 78 meters below the ocean. But here's the thing. This tunnel isn't just about connecting Ningbo and Zhoushan. It's about proving something much bigger. The actual motivation, testing ground for the Taiwan Strait Tunnel. Okay, so let's talk about what nobody's saying out loud. But everyone's thinking, the Gintang Undersea Tunnel is impressive on its own. But many engineers and analysts believe it's actually a test run for something far more ambitious. A tunnel across the Taiwan Strait. Now, if you look at a map, the Taiwan Strait is the body of water separating mainland China from Taiwan. At its narrowest point, it's about 130 kilometers wide. That's roughly 8 times longer than the Gintang Tunnel. The water there is deeper, the currents are stronger, and the geological conditions are even more complex. It would be, without question, the most ambitious tunnel project in human history. But here's the thing. If you're going to attempt something that insane, you don't just jump in and hope for the best. You practice. You build smaller versions. You test your technology, refine your techniques, and figure out what works and what doesn't. That's exactly what the Gintang Tunnel is. It's a proof of concept. It's China saying, we can build a high-speed rail tunnel under the ocean at depths that would crush most structures, with precision measured in centimeters. And we can do it faster and cheaper than anyone else. And if they can do it here, they can do it anywhere. Now, whether or not the Taiwan Strait Tunnel actually gets built is a whole different conversation, one that involves politics, economics, and a ton of other factors. But from a purely engineering standpoint, China just proved it's possible. They've developed the machines, the navigation systems, the construction techniques, and the expertise to pull it off. And that's a big deal because for decades, underwater tunnels were considered one of the final frontiers of civil engineering. They're expensive, dangerous, and technically brutal. Most countries have built maybe 1 or 2 in their entire history. China's cranking them out like it's a weekend project. The Hong Kong-Zhuhai-Macau Bridge, which includes a nearly 7-kilometer underwater tunnel section, was completed in 2018. The Gintang Tunnel will be done in 2028, and there are already plans for more. China's not just building infrastructure, they're building a playbook for how to do the impossible. What this means when one country redefines what's possible. Here's the thing about mega projects like this. They don't just change geography. They change what people think is possible. 50 years ago, a high-speed train at 300 kilometers per hour through a tunnel 78 meters below the ocean would have sounded like fantasy. 20 years ago, it would have been theoretically possible, but economically insane. Today, China's doing it, and they're planning the next one before this one's even finished. That shift matters because when one country demonstrates that something can be done efficiently, other countries start paying attention. Projects considered too risky get reconsidered. Experimental techniques become standard practice, and the entire field of engineering leaps forward. All right, guys, that's it for today's video. If you enjoyed this deep dive into one of the most insane engineering projects on the planet, make sure you hit that like button and subscribe to the channel.